Hello everyone, welcome to CivilPrep. This is a PYQPrep initiative, okay, which is Geography PYQ optional initiative, okay. Now, in this session, we will be looking at one of the PYQ of 2024 from paper 1, that is question number 1B. Formation of temperate cyclone depends on condition of axis of dilation. Elucidate. Now, this is one of the question which was quite difficult, because majority of the students were confused about the concept of axis of dilation. Now, let's understand this question, that what is temperate cyclone and how this axis of dilation it is resulting into the formation of temperate cyclone. Now, when we look at a temperate cyclone, it is forming because of the interaction of fronts. Okay, you might be aware about this part, that is when the fronts they interact, it results into the formation of cyclone. So here we have this is warm air and this is cool air or air mass, and this is warm air mass. When these two air masses, either the warm air mass it approaches towards the cool air mass, or the cool air mass it approaches towards the warm air mass. So what will happen here? The cool air mass and the warm air mass, first they will form a stationary front. Okay, they will first form the stationary front. We can look at from a 3D diagram which is present here. So here we can see there is a, in this blue color, this is cold air mass. And this red one, it is warm air mass. Okay, after this what will happen? This will result into the formation of a neck point. Okay, at this neck point we'll be seeing that at one side there will be warm air and another side there will be cold air. Now after this what will happen? There will be a phenomena which will take place. Here the cold air mass, it will slowly try to push the warm air upwards. Okay, so here we can see that the warm air, it is getting uplifted, and the cool air, as it is dense and moist, therefore it is more heavy. While the warm air mass, it is hot and it is lightweight. Majorly it is dry in nature. Okay, so because of this, the warm air mass being lighter in weight, it starts to get uplifted. Okay, at this junction, this basically results into the starting of the interaction of the air masses. So here we see that there is formation of neck point, and this neck point, this cold air masses, they try to overtake. Okay, they try to overtake the warm air masses, and the warm air masses, they started to move as it is pushed by the cold air masses. So here in this diagram, we can see with a better view. Okay, so here we can see this is a cold air. Okay, this is a cold front. This is a cold front which is formed here. And this is the warm front which is formed in this region. Now, as I rotate this object, here I can see that the cold air mass, it is getting diverged. Okay. At the same time, what I am seeing here that the warm air mass here is also it is getting diverged. Okay. So this is the divergence which is created. Okay. And this is divergence is created along the axis. Now, how it will look like, let's understand this with another diagram. Now, in this condition, what will happen? For example, this is one of the axis. Okay, for example, this is 0 degree, that is equator. This is 30 degree, and this is 60 degree. So here what we see that we have westerlies in this region. Okay, and we have polar easterlies. Now, the polar easterlies, which is moving from 90 degrees to 60 degrees latitude, and they are cold in nature, while the westerlies, they are moving from 30 degree latitude to 60 degree latitude, and they are warm in nature. So because of this, what will happen? There will be formation of front there will be front formation at 60 degree latitude, where both the cold winds or the cold air mass and the warm air mass, they will start to interact. They will start to interact here, resulting into the formation of front. Now, here we'll be seeing that we have warm air which is coming from this region. Okay, here we have warm air which is coming from 30 degree latitude towards 60 degree latitudes. And we have cold winds which is coming from 90 degree latitude towards 60 degree latitude. Okay, this is 60 degree latitude. So here what will happen? After a certain point of time, as this winds, they will start to interact as they will approach the 60 degree latitude. They will start to interact with each other, resulting into the formation of first stationary front. But as these winds they interact, they will start to diverge, because here we'll be seeing that these winds they are getting interacted. Okay, the warm winds they are uplifted above. Okay, this warm winds they are uplifted, and the cold winds they are pushing warm winds from below. So this results into the formation of axis of dilation. So this is the point. This is the point. Okay, this condition and this condition where the divergence is taking place. This is called as the axis of dilation. This is an important condition. This is one of the most important condition which results into the formation of cyclones, or this is the condition of cyclogenesis. Okay, this is the condition of cyclogenesis where the warm fronts and cold fronts they collide. We can see this in diagram also in this model, that how there is interaction of the warm front and the cold front is taking place. And here we can see the cold air, it is pushing up this warm air above. Okay, we can change here this part here. And we can see that the warm air, it is getting upward. This is the warm air. It is getting uplifted. Okay, so that here in this part, we were able to better understand the formation of warm front and the cold front here in this diagram. Okay. So this is a condition. This was the basic question which was asked in the UPSC examination. Okay, that is the formation of temperate cyclones depend on the condition of axis of dilation. So here we are able to explain that how the fronts are being formed, how the interaction is taking place. Okay, we can understand this with this 3D model, and we can see this the axis of dilation concept where there is interaction of the warm air and the cold air is taking place. Now, after this, we can see the formation of temperate cyclone, which is explained very well by two concepts. Number one, the polar front theory. Okay, under the polar front theory, initially there is formation of stationary front, then there is formation of mature fronts. Okay, after maturing, it results into the occlusion or occluded fronts. And later on, there is death of cyclone with respect to dissipation. Okay, so in this part, we'll be seeing that the axis of dilation, it is formed under the stationary front and the mature front. So these two stages, it provides us that how there is formation of axis of dilation. Now this axis of dilation, it is majorly forming. Okay, here we'll be seeing that this is majorly formed at the upper troposphere, which is more than 3 kilometers from the surface of Earth. Okay, and these fronts, they are also they are also influenced by the jet stream. Okay, this influence of jet stream, it is also called as baroclinic instability, where the baroclinic instability concept explains well the temperature gradient which is present in the atmosphere, or we can say the troposphere, which helps in the formation or sharp changes in temperature and pressure, which is suitable for the formation of this temperate cyclones. Okay, so this is the condition of here we can see that this is the condition of formation of cyclone. Okay, and this is the concept of axis of dilation. Okay, so here we can use the polar front theory. Okay, we can use the jet stream theory. That is, we can also provide here the Baroclinic instability, which helps us to realize that how this formation of fronts is taking place. Now, if we look at certain examples, the nor'easters in North America. Then number two, the cyclones over North Atlantic. And number three, the Mediterranean depressions. They are basically the examples of temperate cyclones. Thus, concluding this question, here we'll be seeing that the axis of dilation it governs the divergence and ascent or uplift, which is necessary for the formation of temperate cyclones. Okay, here one catch is there. Here one catch is there. What is this catch here? The orientation. The orientation of this axis of dilation is crucial for front development. Okay, which is basically seen as fundamental kinetic control in mid-latitude atmospheric dynamics. Now, what this statement it is trying to explain here, let's see in detail. Now, this is the axis, or we can say this is Earth. Okay, this is the axis of dilation where we see the cold waves or the cold air, it is dilating here, while the warm waves, they are dilating here. Okay, if this axis it is almost 45 degrees or more, so this will result into the cyclogenesis. But if this axis it is less than 45 degree, So this will not result into the formation of temperate cyclones. So this is the axis of dilation, which is crucial. The angle of this axis set is crucial for understanding or the favorable conditions for the formation of temperate cyclone. Okay, so guys, this is the question. We can take the note here. This is also an important part here. Why we are discussing this? Because the same concept, on the basis of same concept, the question can be asked in the next year UPSC examination. So, okay, so guys, this is a PYQ of 2024, question number 1B. The formation of temperate cyclone, which depends on the condition of axis of dilation, elucidate. Okay, so if you find this video resourceful, meaningful, okay, which help to clear your concepts and understanding, do comment in the comment box, do like, do share, do subscribe. Okay, do share it with your friends who are also struggling to understand the same concept. So guys, see you in the next question. All the best and thank you.